Hi, welcome to another video, and in this video I want us to introduce partial differentiation, and we do a number of examples on partial differentiation. What we have been doing for the last few lessons is complete differentiation, whereby you have been working with a function, say y, which is a function of x. Now in this case we have one dependent variable, which is y, and one independent variable, which is x. In that case, you perform a complete differentiation, or you get a complete derivative, and it's usually denoted by derivative of y with respect to x. This is read as derivative of y with respect to x. Now, what if you have one dependent variable and several independent variables? For example, we have a function z which is dependent on two independent variables. This is a dependent variable z. Here we have two independent variables. So if you have a function or a variable z, this is dependent variable. We have a variable z that is dependent on two other variables, x and y. An example in real life that we can give is, for example, we are trying to investigate the growth of some plants. What can affect growth of plants in a greenhouse? It could be the temperature or the warmth, the moisture content of the soil or the moisture. It could be also the light intensity, and so on. So in this case, the growth of the plant is the dependent variable. It's depending on the temperature, moisture content, and the light intensity. In both cases, if you are told to differentiate, in this case we will not do, or we will not find complete derivative, but instead we will find partial derivatives. We can investigate what is happening to the plant if we try to change the temperature holding moisture content and light intensity constant. In that case, you find rate of growth of the plant with respect to temperature change. You change the temperatures, but you do not change the moisture content and the light intensity. This is a partial derivative. Or we can also find the partial derivative of g with respect to m. You try to change the moisture content in the soil, in the greenhouse, but you hold the temperature and the light intensity constants. So in partial derivatives, you investigate what is happening to this variable here as you change one but hold others constant. So that is it. I hope that it gives you a picture of what we mean when we talk of partial differentiation or partial derivative. But maybe you can put that in a sentence. E.g., if you have z is equal to a function of x and y. Also use z as the dependent variable and x and y as the independent variable. To evaluate a partial derivative, we differentiate z with respect to x, where holding y constant, and then finally we differentiate z with respect to y, where holding x constant. X constant. So here, this is partial derivative of z with respect to x. This one partial derivative of z with respect to y. Of course, here we'll be holding y constant, or you'll be treating y as a constant, and here you'll be treating x as a constant. This one we can also call it rate of change of z in x direction. We can also call it slope of z in x direction. You see, a derivative is the same as rate of change, and is also the same as the gradient or the slope of that variable in a certain direction. The same thing, this one we can say is rate of change of z in y direction, or slope of z in y direction. Whichever way you want to refer to that, it can be a rate of change, it can be a slope or a gradient, or it can be a derivative. Now, so these two, just as we did previously, these two z with respect to y, they are called first order partial derivatives. Now suppose we take this first order partial derivative of z with respect to x, and now we differentiate again with respect to x. The first order partial derivative of z with respect to x, we differentiate it again with respect to x. This is called the second order partial derivative of z with respect to x. Yeah. Which can also be denoted as first order, which can also be denoted as second order partial derivative of the function of x and y with respect to x. Like that. You can also denote it as that, or using this symbol fxx. All these mean the same thing. One question can tell you to find this, another can tell you to find this, another question can tell you to find this. They all mean the same. The second order derivative of the variable z with respect to x. If you now take this first order partial derivative of z with respect to y, and you are told to find it, to differentiate it again with respect to x. First order partial derivative of z with respect to y, then we are told to differentiate again with respect to x. This will be a second order partial derivative of z, first with respect to y and then with respect to x. which can also be denoted as second order partial derivative of the function of xy with respect to, first with respect to y and then with respect to x, which is denoted with by that. See, mathematics is a language. You have to understand what something means so that you can know what you are supposed to get. Suppose now we take what was differentiated with respect to y, then we differentiate it again with respect to y. What does this give us? Second order partial derivative of the function z with respect to y, which can be denoted as that second order derivative of the function of x and y differentiated with respect to y, which can be denoted as that. And finally, suppose we take what was differentiated with respect to x, then we differentiate again with respect to y. This is denoted as the second order derivative of z, first with respect to x, then with respect to y, which we can denote as second order derivative of the function of x and y with respect to first with respect to x and then with respect to y, which is denoted as fxy. As I'm telling you, mathematics is a language. You have to understand that language. Just as you need to understand a language like Swahili or English or another language like German or something, you also have to understand the language of mathematics so that you can be able to evaluate problems in an exam. So, these two number 2 and number 4 are called mixed derivatives. Number 2 and 4, they are called mixed derivatives because they are mixing the derivatives first with respect to y and then with respect to x. First with respect to x and then with respect to y. Sometimes these two are equal, sometimes they are not. Now, we can try to solve a number of problems. In the exam. I hope we can find some basic examples that we can start with. Club certificate, electrical, ENG. Which year? October 2021. October 2021. Which question? 7a. Given the function of x and y equal to x squared y plus 3y cubed x, determine number 1, partial derivative of the function with respect to x. Number 2, second order partial derivative of the function with respect to x. Number 3, second order partial derivative of the function first with respect to x and then with respect to y. Let us solve that. So we take our function of x and y, which is equal to x squared y plus 3 y cubed x. So let us differentiate with respect to x. So this is, if you differentiate here, the variable you are considering is x. We treat y as a constant, just like a number like 2, 10. So if you differentiate this one, it will give us 2xy plus, here we are considering x as a variable. So 3y cubed is a constant. So since if you differentiate x with respect to x, it will disappear, so you have 3y cubed. If you now differentiate again this first order derivative, if you differentiate it again, you get a second order partial derivative of the function with respect to x. You differentiate this with respect to x, you are considering x as your variable. You differentiate this x with respect to x, it will disappear to get to y is a constant. Since y is a constant, if you differentiate y, 3y cubed, which is a constant, it will disappear. To get this one, the second order partial derivative of the function with respect, first with respect to x, and then with respect to y, we are going to take this, whatever you differentiated with respect to x. This time round you differentiated to y. So what are you differentiating with respect to y? Whatever you differentiated with respect to x. 2x y plus 3y squared. Since now we are differentiating with respect to y, we will be holding x as a constant. We differentiate this y with respect to y, it will disappear and you will be left with 2x. If you differentiate 3y squared, it's not y squared, it's y cubed. If you differentiate 3y cubed, you are differentiating with respect to y. This now will be 9y squared. It will be 9y squared. So that's how you go about that one. I think that one was pretty simple. Let us get another one. Let's get another one. This is diploma in electrical PNG June, July 2017. June, July 2017. We are told 7a, given u is equal to x minus 3y all over x plus 3y, show that x, partial derivative of u with respect to y, no, with respect to x here, x, partial derivative of u with respect to x plus y, partial derivative of u with respect to y is equal to 0. Let's try to solve that one. See, we have u is equal to x minus 3y all over x plus 3y. Let me see whether I made a mistake. No. If you have to get partial derivative of u with respect to x, I think the best thing here is to use quotient rule. Quotient rule. Let us call this one W. I don't know whether you're using V anywhere. W and V. W over V. What will be the partial derivative? It will be V using quotient rule. Partial derivative of W with respect to x minus w partial derivative of v with respect to x all over v squared. All over v squared. I think we have already seen this formula. I don't need to explain much. Now we take v. What is v? X plus 3y. Let us differentiate w, but this time with respect to x. If you differentiate our w, which is x minus 3y, with respect to x, this y is a constant, it will disappear. When you differentiate x with respect to x, you get 1. Minus, we take w. What is our w? X minus 3y. X minus 3y. But then you multiply with derivative of v with respect to x. Differentiate this one with respect to x. 3y is a constant, it will disappear. If you differentiate x with respect to x, you get 1 all over v squared, which is x plus 3y. Then you can open the bracket. This is x plus 3y, yeah, minus x plus 3y all over, oh, this one should be squared because this is v squared. Squared. This will be, this and this disappear, 6 y over x plus 3y squared. Okay, let us remove this. The next one, we need to get what? I've already removed the question. No, we need to get this partial derivative of u with respect to y. Again, let us go here. What is our u? W over v. But we are differentiating with respect to y this time round. We know how we do it. Write the formula for quotient, because that is a quotient. It is v partial derivative of w, but this time with respect to y, minus w partial derivative of v with respect to y, all over v squared. Which is, what is our v? The denominator, x plus 3y. Differentiate w with respect to y. Of course, x is a constant, it will disappear. If you differentiate 3y with respect to y, it will be negative 3. Minus w, what is our w? X minus 3y times partial derivative of v with respect to y. This one, v, differentiate with respect to y. X is a constant, it will disappear. 3y, when you differentiate with respect to y, you get 3. All over x plus 3y squared. So open the bracket or simplify. Negative 3x minus 9y. Yeah, this and this minus 3x. This negative, you open this one and then you multiply 3. Positive 9y all over x plus 3y squared now becomes, this will disappear to be negative 6x all over x plus 3y squared. Now we prove that. Do that in that equation. We will need x times partial derivative of u with respect to x. Partial derivative of u with respect to x, 6y all over x plus 3y squared plus y times partial derivative of u with respect to y, partial derivative of u with respect to y, which is this, negative 6x all over x plus 3y squared. which now is equal to 6xy over x plus 3y squared minus this, make this minus 6xy 1 over x plus 3y squared, which will give you 0, because negative positive will give you 0. So by the way, how much was that question? That question was 5 marks. I don't know whether you think that is less or is enough. By the end of the day, the most important thing is knowing how to do it, because even if it's awarded 10 or 20, it won't make any sense if you do not know how to do it.